In today's video, we're going to use SAM2 to generate the segmentation on the right side. Meta has released a Segment Anything Model 2, which is called SAM2, that can do segmentation for videos, not just images, as the SAM1. In SAM2, we can actually click and select the object, and it can keep track of the same object over a short time of window. You can try the online demo, and on the demo, we can choose the shoes, we can add another object, choose another shoes, and we can also choose the ball and start the tracking. And for a couple of seconds, we'll finish the tracking for the 3 objects. The online demo has a limitation of 3, but the offline version doesn't have this limitation, and you can change the effect. You can choose an emoji or spotlight or pixel art. You can choose a gradient, and you can also manipulate the background as well. Like for example, like erased the background, we can use gradient, pixel art. If you double click the effect, it will have multiple versions of the effect, which is very cool. So using the SAM2 model, we can actually you can develop many applications. For example, if you want to keep track of some object or create some kind of arty visual effect. So let's learn how to install the software. In the beginning, we need to install Anaconda. You can go to this website and download the corresponding version. It can be applied for Windows, Mac OS. And then we need to install the CUDA Toolkit 11.8, and we need GPU machine to run this code. After you finish installing the Anaconda, we need to use the Anaconda prompt. And in the beginning, the first step would be create a Anaconda virtual environment. So we're going to use conda create SAM2 test. The Python version going to be 3.11. Then we're gonna activate the Anaconda virtual environment. Use conda activate SAM2 test. Next step would be git clone the segment anything to repository. In my machine, I have already downloaded this one. So in your side, from your side, you probably have to wait a couple of minutes for it. Then let's change the directory to segment anything to folder. Use cd segment anything to. Then we need to install the Torch Vision, and Torch Audio that can be compatible with CUDA 11.8. We're going to use pip install Torch. The Torch version is going to be 2.31, and the Torch version, the Torch Vision, is going to be 0.18.1. The Torch Audio going to be 2.3.1, and we're going to define their version going to be compatible with the CUDA 11.8. If you follow the official instruction using pip install e dot, you're probably gonna find this home directory issue. The CUDA home directory, it tells you how to change the repository, which is gonna be hard to solve for now. So we're gonna manually install some of the dependencies to make this up and running. So the first one is pip install hydrocore. HYDRA-core. This is the first one. So second one would be the pip install tqdm. Then we're going to install the pip install matplotlib. Next one would be pip install opencv-python. The final step would be to pip install the Ninja. So after we prepare everything, we're going to use python setup.py, build extension, -- in place to finish everything. Now let's verify the installation. So let's type in Python to activate the Python Then we're going to use import SAM2. If you don't see any error message, that means congratulations, you have successfully installed SAM2 in your machine. And let's now explore how to use SAM2 to segment some object in your example video. Before we dive into the code, we also need to download the checkpoint from the SAM2 website. Let's go to this website and click the large model. SAM2 Hera large and put in the corresponding author, the segment anything to, and checkpoint subfolder, and make sure your large.pd file is in this folder. And also check the configuration file folder and find the large configuration file. In the root folder, let's create a sam2_test.py. We also need to check in the notebook, videos, bedroom, the folder, you have all the example images after the git clone, and you can see all these frames over in this folder. Let's open sam2_test.py. We need to first import os torch numpy matplotlib pil image.io, because at the end we're gonna create a GIF creation. First of all, we need to enable the automatic casting for mixed precision training. And also we're gonna check if the CUDA version, the major version, is larger than 8. Then next, we're gonna import sam2 build sam to import the sam2 video predictor. We also need to define the directory of the sam2 checkpoint, which is in this folder, right? And also the model configuration file that has to match, which is also for the large model. So you can check your directory. For example, you can open the checkpoint, make sure your checkpoint is over here, and also the configuration file, and find the corresponding configuration file as well. So make sure the directory is correct. Then we're going to generate this video predictor by providing the model configuration file and also the sam2 checkpoint. We're going to define the show mask function, which is going to display the mask image on top of the raw image. And also this show point function, which is gonna show the correct and like positive and negative points on top of this image, but which is not going to be shown in this video. Define the video input folder. You can change this directory to your customized directory as well, but here we're gonna use the example one, which is in the notebook, videos, and the bedrooms. Show like different frames, continuous frames of the video. And after that, we're gonna like index all the frames in the folder and sort them based on the numeric numbers. And we're gonna display the first frame of the video for us to click on the video, and we're gonna initiate the points and labels. So we're gonna have an interactive choice, right? So we're gonna define this onClick function. We're gonna use our mouse cursor to choose the object we want to track or do the segmentation in the video, right? Then we're gonna connect the click point to the function. We're gonna save this button press event and return this kind of positive and negative points. But here we're going to choose one single positive points, and we're going to define the points either as positive or negative for the segmentation training. Now we need to initiate the inference status and then initiate the frame index and object index. Here we're going to show the example to trace or segment one single object. And we'll also need to process the collected points, and we need to show the results on the current frame after the processing. So after the processing, we want to visualize the results and also generate GIF file and save it in the root folder. So we're gonna define the out frame index. All the code can be found in the corresponding video description, and you can download the script for you. You can play with the code and run it on your local machine. And let's create the final part, which is to generate the GIF image. We're gonna save all the frames as a GIF file, and you can visualize all the results and test this code for fun, right? We're gonna append it every frames to the previous frame and save this file as GIF file in your local directory, as you can define the names of the GIF file and keep the durations based on your personal preference. All right, cool. So we're gonna finally we're gonna save this file and run this Python code in your environment. All right. You can open the Anaconda prompt. Make sure your working directory is in the segment anything2 folder. So we're gonna use Python, and we're gonna use Python sam2_test.py because you are in this folder, so you don't have to change any directory or provide the more detailed position of this Python code. Simply use Python sam test.py, and you're gonna see this image, which is the first frame, and you can click on the image. For example, you can click on the shirt and type in 1 for positive. So we're gonna keep track of this object, and then close the figure or hit enter button. But normally, if you just close the image, the processing will automatically start it. So let's close this image, and we're gonna first load the frames for each frame. And then you're gonna propagate this prediction throughout the images because it's like frame by frame in the whole video. So you're gonna process all the frames. This will gonna take like a couple of seconds. Cool. The predicted GIF file, the generate GIF file, you can find this one in the segment anything2 folder, and you'll see this object will be traced and segmented, tracked through all the frames, which is working perfect. Thank you for watching this video. Please subscribe and comment below and see if you have any interested or want me to explain this paper in more detail. Please subscribe and see you next time.